Hey guys, this is Dipesh, and in this particular video we'll be looking into a new type of problem in machine learning called as clustering problem. Okay, and we'll see what are the various algorithms that we can use to solve this problem. All right. So in our first lecture, I told you that in machine learning we have basically three main types of machine learning. First is supervised learning, second is unsupervised learning, and the third is reinforcement learning. And each type of machine learning basically solve a particular type of problem. So supervised machine learning solves classification and regression problem, which we have already discussed in our fourth and fifth lecture. Okay, so now in this video we'll be looking into unsupervised learning. Okay, and unsupervised learning basically solve in unsupervised learning we basically solve a different type of problem called as clustering problem. Okay, we'll look into what supervised means, what unsupervised means, and what is the major difference between them. Okay, so yeah, let's get started. So first I will tell you what is the difference, what is unsupervised learning, what is labeled data and unlabeled data, and then we'll move into the clustering problem, and then we'll discuss a popular algorithm called as k-means clustering, which is used to solve clustering problems. And at the end, what we'll do is we'll try to implement k-means algorithm or k-means model using Python. So in the field of data science or in the field of machine learning, we have basically two types of data sets. First is labeled data set, and the second is unlabeled data set. Okay, now if I give you a straightforward example here, then let's say that we have images of dogs and cats. Okay, so here you can see that the left side basically represents labeled data. Okay, whereas the right side represents unlabeled data. Now what labeled data is basically a group of samples that have been tagged with one or more label. For example, a data label might indicate whether a photo contains a horse or cow. Okay, so put simply, labeled data basically means data which has been labeled. Okay, so here you can see that we have four images, and each image is basically labeled. So we know so this image basically has been labeled as cat, and again this image has been labeled as dog. Okay, now as a human we know that these images represent cat, and this image basically represents dog, but the machine does not know such things. Alright, so in order to basically make the machine aware about what exactly does this image mean, or what exactly does this piece of data means, we have to label the data. Okay, now again in label dataset we basically saw that we have labels. Okay, so this we have data which has been labeled. So in this case we saw that these are images, and each image has been labeled. Now in case of unlabeled dataset we don't have such labels. Okay, we don't have these labels. Now if we gave any machine learning algorithm these raw images, then it would be very difficult for it. The machine learning model won't be able to recognize if this image contains a dog or a cat, because we haven't given the model the labels. We never gave if we never gave the model these labels, then the model will never know if this image contains dog or not. So this is basically labeled data, and this is called as unlabeled data. All right, so if we look into some structured data, okay, if we look in the context of structured data, then unlabeled data set will include this part. Okay, and labeled data set will also include this part. So this is basically an example dataset for diabetes. So we saw in our previous lecture that age we saw that age, glucose and BMI are our independent variable, and the target variable is the outcome column, which is a categorical variable. So basically each row represents data about a person, okay, data about a person's body. All right, and the target variable basically indicates if the person has diabetes or no. All right, now in the context of structured data, if we just forget about this target variable, okay, if we just forget about this target variable, then the data that is remaining, we can call this as unlabeled data, okay, because we know that this data is about diabetes test, but we do not know if a person has a diabetes or not. We do not have target variables here. We just have this raw data here. We cannot use this data. We cannot use this data to predict diabetes, because because in our unlabeled dataset, we don't have the target variable. Okay. Now let me repeat this again. So this part, if we forget about the outcome column, then the remaining part of data, we can call this as unlabeled data. But if we consider the data set as a whole, then this would be a labeled data. Okay, this would be a labeled data set, because now we have our x values and we have our y values. We can train the model and say that model that, okay, these are the values, these are our independent variables, and these are our dependent variables. So whenever you find such data, you have to basically predict the target variable like this. We can train a model like this. So this is basically a main difference between labeled data and unlabeled data. Now why I am telling this is because in supervised and unsupervised machine learning, in supervised and unsupervised machine learning, the major difference is between the type of data that is used to train the machine learning models. Okay, so moving forward, the main distinction or the main difference between the two approaches is that supervised learning algorithms use labeled input and output data, while unsupervised learning algorithms use unlabeled data. Okay. So also one important thing that you should remember is, whenever we talk about supervised machine learning, okay, in supervised machine learning, basically we are always trying to predict the outcomes. Okay, we are always trying to predict some outcome or predict some output. Okay, whereas in unsupervised machine learning, we train a unsupervised machine learning algorithm to basically get insights from the data. Okay, to get insights from the data. So for example, we saw that in supervised machine learning, we can solve two types of problems, that is classification and regression problem. Okay, now as we saw what classification and regression in our previous lecture, in both these types of problem, what we do is we predict a certain value. In regression problem, we basically try to predict a continuous variable, whereas in classification problem, we try to predict a categorical variable. Okay, but in unsupervised learning, we don't have any such thing. In unsupervised machine learning, we don't train the model with the intention to predict some value. Okay, in unsupervised learning, mostly what we do, the reason why we train a unsupervised machine learning algorithm is to basically get insights from the data. Okay, to get more insights from the data. Also, in the note here is that since supervised learning solves regression and classification problems, they by the nature of their problem by default require labeled data. Now as I said earlier, for example, let's say we trained a logistic regression model to predict if the given image belongs to the cat or dog. Now in order to train a model, we have to tell the model that, okay, this is belongs to a cat, and this image belongs to a dog. Okay, because in order to classify this, in order to train the model itself, we would have to provide the model a labeled data. Okay, but in unsupervised learning, we don't need we don't need labeled data, because we are not trying to predict something here. Okay, all right. So again, you can see this image here. If you consider this part, if you consider this part, now you can see that we have x1 and x2, which are our independent variable, and the label is basically our target variable. Okay, so this is basically a label data set, and this will be used for training a supervised machine learning algorithm, or a supervised learning model. Okay, but if we look at the other part of the data, okay, if we look at this part, we have independent variables, we have x1 and x2, but we don't have labels. Okay, now this is basically unlabeled data, and this data cannot be used to train a supervised machine learning. This data can be used to train a unsupervised machine learning model. All right. Now there is also a third type of machine learning called as semi-supervised machine learning. Okay, so don't worry about this right now. In future videos, we will try to cover this too. Okay, just remember that semi-supervised learning machine learning is basically a combination of supervised and unsupervised machine learning. Okay, so semi-supervised machine learning models can basically use this type of data, which contains both labeled and unlabeled data. All right. So yeah, basically in general, every machine learning model think of every machine learning model as a function of its input. Okay, because in every machine learning model, okay, more specifically in every supervised machine learning model, we have certain inputs. We have certain inputs, and we try to map the model with a certain output. Okay, so if you consider a machine learning model as a function, then our input, basically with what we do is we try to map the inputs to a particular output. Okay, now output here can be anything. It can be a continuous value or a categorical value. Okay, but in case of unsupervised learning, we don't have this y. Okay, we don't have this y. We don't train a unsupervised machine learning model to create such mapping. We don't train the unsupervised machine learning model to predict something. We train a unsupervised machine learning model to get insights from this data itself. Okay, to get insights from our data. Okay, so I guess this should be all clear until by now. It's not very hard. Okay, so moving forward, let's look into what is a clustering problem. Okay, so basically the clustering problem is the method of identifying similar groups of data in a data set. Okay, so what is clustering? Clustering is a method of identifying similar groups of data in a data set. Okay, and entities in each group are comparatively more similar to entities of that group than those of other groups. Okay, so let's get more into it. Now imagine that this is our test data set. Okay, now imagine this is our test data set. Okay, this data set basically is a data about some mall customers. Okay, some data about people going for shopping in a mall. Okay, and each row basically represents data about one person. Okay, one person, and some of the data that we have about them is their gender, we have their age, we also have their annual income. Okay, annual income in dollars, and we also have the spending score. Okay, so spending score is basically a value between 0 and 100. The higher your spending score is, a higher spending score basically represents that this person is a very frequent buyer. Okay, whereas a lower spending score basically represents that this person is not a very frequent buyer. All right, so let me correct some values here. Let's do it as 19,000. So let me do this as 30,000. All right, so moving forward, so this is our data set here. Now you can see that we don't have any y value here. Okay, we don't have any target variable here. All of all these variables are basically our independent variables here. Okay, there is no target variable here. We are now not trying to predict anything. What our main goal here is to get some insights from this data set. Okay, to get some insights from this data set. Okay, so now what let's say that we created a scatter plot of spending score against age. Okay, so we created a scatter plot of age versus the spending score. Okay, and this is basically a kind of scatter plot that we get. Let me remove this. Okay, now this is basically a kind of scatter plot that we get. Now what will happen is, when we apply when we train our clustering model here. Okay, basically in a clustering problem, what we're trying to do is we're trying to find clusters of data, or we are trying to find groups of data which are very similar to each other. So if we look more carefully in our data set, we'll see basically three different groups here. Okay, we'll see three different groups here which are in which the data points are very close to each other. So it would be, let's say, this. Okay, let me clear this. Okay, we can see that the data points in this particular cluster are very close to each other. Okay, now again another cluster that we can form here is this. Now we can see that the data points in this particular group are close to each other. Basically what this means is that these values are very similar to each other. Now other cluster that we can form is this. Okay, so as we can see that now what we have done is we have created three clusters here. Okay, basically cluster means a group of data points here. Okay, now each value here, each point basically represents a particular customer. Okay, now if this particular basically each data point represents one particular customer. Okay, one particular sample from our data set. So what this means is that if we created these clusters, then each value belonging to that particular cluster is kind of very similar to each other. Alright, so in a clustering problem, what we do is we try to find such similar groups of data in our data set. Okay, more specifically, we try to find clusters of data in our data set. Okay, and the data points inside each cluster are very similar to each other. Alright, let me clear this. Alright, so here, as you can see here, each cluster consists of data points which are very similar to each other. Now, as I said again, we are not trying to predict anything here. We are basically trying to get insights from here. So now if you look very carefully, we will see that the people between the age of 20 and 40, okay, have a higher spending score. Okay, so people in between the age or in the range of 20 and 40 have a higher spending score, which means they shop a lot. Okay, they shop a lot and they spend a lot of money. Okay, whereas people between the age of 40 and 60, as you can see, don't have a lower spending score, which means people in between the age of 40 and 60 spend less money on shopping. All right, now how you can use this insight? So what we can do is, we can let's say you have a social media application. Okay, let's say you have a social media application. Now what we can do is, since we know that these people, okay, these groups data points are very similar to each other, what we can do is, we can target them, we can show them different ads. Okay, we can show them different advertisement. Now we know that this basically people inside this cluster shop a lot. So what we can do is, we can show them more ads. Okay, more ads, more advertisements. Okay, about products. Okay, so basically this cluster, one application of this particular problem is basically that once we know the clusters, what we can do is, we can target the we can let's say we have a social media app. Okay, then what we can do is, we can show different advertisements to this people belonging to this each cluster. Okay, so this is one application, how you can basically use clustering problem. Okay, how you can use the insights from a clustering problem for your own advantage. All right, so again, we are not trying to predict here, we are not trying to predict spending score, or we are not trying to predict age or anything. We are just trying to get an insight here, insight from our data. All right, all we did was basically found out groups which are similar to each other. All right, so how do we find these groups? Now again, like let me just remove this again. All right, now again, let's say that I have this plain data set. Okay, I have this plain data set. Okay, now how do we train a model? How do we train a model to find these clusters? Now in order to find these clusters in our data set, okay, now again, like in our data set, basically we don't have much data here. All right, now I just randomly drew this scatter plot. Okay, but in real world the scenario, in real world, basically you may have millions of customers. So it is very important that you it is very important that you use that you basically find accurate clusters. Okay, accurate clusters of your data sets. Okay, so how do we find these clusters in the most optimal and the most accurate manner possible? For that particular thing, we have many different clustering algorithms in machine learning. Okay, we have many different types of clustering algorithms, and some of them are k-means clustering. Okay, mean shift clustering, DBSCAN, and all this. So basically, in unsupervised machine learning, we try to solve a particular type of problem called as clustering problem. And unsupervised machine learning basically consists of many such algorithms or models which we can use to find these clusters in our data set. Okay, now in this particular video, we'll look into k-means clustering, which is basically the most basic type of algorithm that you can use for finding clusters in your dataset. All right. So yeah, let's get started. Now, so now we know that what now we know what clustering problem is, okay, and what are we trying to do here in this particular problem. Now let's look into k-means clustering, which is an algorithm that we can use to find clusters in our dataset. All right, so simply put, clustering is a machine learning algorithm that helps us find similar clusters in our data. Okay, and the k represents the number of clusters or centroids. Now it is very important that you understand what this k means. Okay, this k is basically a numerical value. Okay, it is basically a discrete value. Now what this k represents is basically number of clusters in your data set. Okay, so k can be anything, like k can be either 2 or 3. You know, in this data set, in this particular data set, if we draw our clusters, let me clear this. In this data set, if we, let's say, if we draw two clusters, okay, if we draw two clusters, then our k will be 2. Okay, then our k will be 2. K basically represents the number of clusters in our data set. Okay, so again, like if I draw, let's say, 3 clusters here, like this, and this is our third cluster, then k would be 3. Okay, so simply put, k represents the number of clusters in our data set. All right, now you can see the image. This is before applying k-means algorithm, okay, or k-means cluster model, and after applying this model, we can see that the model has successfully found out that there are 3 clusters in our data set. All right, now again, like, the model does not predict how many clusters there are in our data set. Okay, let me write this here. The rather k means does not predict how many clusters are there in our data set. Okay, but rather what it does is basically it tries to basically found out which cluster, finds which cluster do each data point belongs to. Okay, so now if I say that this data point, okay, let's say this data point, okay, this data point basically at the beginning, before applying k-means, this data point does not belong to any cluster here. Okay, but after applying k-means, we can see that the data set, the data point basically now belongs to a cluster. So basically what we do in k-means clustering is we identify which cluster do each data point belongs to. Okay, so if I say that there are 3 clusters, you know, if I say that there are 3 clusters, then what the k-means algorithm will do is it will basically find which cluster does each data point belongs to. All right, okay, so another very important thing to note here is that in k-means, the model will not decide the most optimal k by itself. We have to provide it with an optimal value for k. Okay, now in k, basically k is not a learning parameter for our model. K is basically what we call a hyperparameter. Okay, what we call as a hyperparameter. let me explain this here. K is basically a hyperparameter. Now what is a hyperparameter? Hyperparameter is the value of a parameter that we have to basically we have to pass to the model. Okay, like hyperparameter is the value we have to give the model before training. Okay, so K is basically a hyperparameter here. Okay, the model will not learn how many clusters. The model will basically find the accurate clusters here. Basically, let me repeat this again. The model will not find the number of clusters for us. Okay, as I said you, K-means does not predict how many clusters are there in our dataset. Okay, it just assigns it just, if we say that there are three clusters in our dataset, then it will basically find which cluster do each data point belongs to. Okay, so now again, like if I say here, let me remove this. Basically, if I say that there are let's say 4 clusters here. Okay, 4 clusters here. Let's create 4 clusters. Okay, if I give K is equal to 4, okay, K is equal to 4 to the K-means algorithm, K-means model, then what we are telling the model is find 4 clusters in our data set. Okay, we are explicitly basically telling the model to find 4 clusters here. Now what K-means clustering will do is it will find out, basically it will basically find like it will find out which cluster do each data point belongs to. Okay, provided that there are 4 clusters in our data set, it will predict which cluster do each data point basically belongs to. All right, so we as a user, we have to provide the number of K's here. Okay, the model will not predict the if you gave the number of clusters as, let's say, 10, then the model will basically find 10 clusters in our data set. If you say K is equal to 20, then the model will try its best to find 20 clusters in your data set. Okay, so K is basically a hyperparameter. Alright, so how do we perform this technique here? How does K-means clustering actually work? Now basically there are two main steps in this algorithm. Okay, so the first step is, let's say this is our data set. Okay, I'm not assigning any labels here. Let's just assume that this is our scatter plot. Okay, now I'm giving you this example in a visual manner. Okay, I'm giving you this example in a visual manner as a scatter plot. Okay, now just imagine that we have this scatter plot here and we want to find clusters here. Okay, we want to find clusters here. So now what we'll do is, firstly, the first thing that you will do is you will decide a value of K. Okay, now don't worry about how we will decide the optimal value of K. moving forward, I will tell you a special method called as elbow method. So using elbow method, we try to basically try to train model multiple times using different values of k, and we then choose the most optimal model here. Okay, so don't worry about choosing the most optimal value for k yet. So now just just see how the k-means algorithm actually works here, and how it basically tries to form the clusters. So now this is basically our example data set. Okay, so the first step that you'll do is you will decide for a value of k. Okay, first thing that you will do, you will choose a value of k. So let's say I choose that k is equal to I choose k is equal to 2 here. Okay, k is equal to 2. K is equal to 2 basically represents that we want the k-means algorithm to find two clusters in our data set. Okay, to find two clusters in our data set. So now what this how this model will work is, firstly what it will do is, depending on the number of clusters k, you pick k random points from the dataset as centroids. Alright, so what we did is we choose a value for k, and the next step would be choosing two random values. So choosing k random values in our dataset. So what I will do is I will choose any two random data points here in our dataset. So So what I will do is I will choose now k random points here. So since our k is 2, I will randomly choose any two data points here. So what I will do is I will choose this one. Okay, and another point that I will choose is this one. Okay, now I am randomly selecting these values here. This is how the k-means algorithm actually works. You give it the value of k, and it will randomly select k data points from your data set. So next step what you have to do is calculate the distance of each data point from all the other centroids using so calculate the distance of each data point from all the other centroids using the Euclidean distance formula. Okay, and assign each data point to a centroids cluster. Okay, now centroid is basically this. Okay, this random point that we chose, this will be our centroid. Okay, this will be our centroid. Let me write this here. Centroid basically refers to a center of the cluster. Centroid. Now the k-means clustering algorithm is a bit complicated, still a bit complicated. I'm just giving you a high level overview of how the major parts of this algorithm actually work. Okay, so now again this is centroid. Okay, so the two random values that we chose, those two random points will be our centroids. Okay, now let me remove them again. Okay, so now we know that these two random points will be our centroid. So what we have to do is we now the next thing that we will do is we'll calculate the distance of each point. Okay, we'll calculate the distance of each point with the centroids, and then accordingly we'll assign the clusters. Okay, so now for example let's pick this let's say that this value. Okay, this data point here. So what we'll do is we'll calculate the distance of this point with both our centroids. Okay, we'll calculate the distance of this centroids with both the centroids. So this is basically our data points, and if we look at which centroid is closer, we can clearly see that the first centroid is much closer to our data point. So if this is our data point, then we know that this centroid is much closer to our data point as compared to this data point, this centroid. Okay, so what we did was we chose k random values here, k random data points on our data set, and these data points are now our centroids. Okay, and what we are now doing is we are finding the distance of each point. Okay, we will find the distance of each point from the from both these centroids. Okay, so let me clear this and tell you again, so the concept gets more clear. So these two are our centroids. Okay, now what will do is we'll calculate the distance of all the points with these two centroids. Okay, so for example, let me pick a point again. So let's say I pick this point. Okay, this point. Now what I have to do is I have to find the distance of this point from both the centroids. So what I'll do is I'll find the distance. Okay, I'll find the distance. Now let's say that this distance is, let's say this distance is 5 units, and this distance is 15 units. Okay, now the first centroid, okay, now the first centroid is much closer to our data point. Okay, we know that this centroid is much closer to our data point, and this centroid is much farther to our chosen data point. So what we'll do is with this, now this point will basically now belong to the cluster of this centroid. Okay, now so this data point, let me repeat this again. So this point, since it is closest to our first centroid, it will belong to the cluster of this first the cluster of this first centroid. Okay, so what we'll do is we'll do the same thing for all these data points. Okay, and each data point here will basically belong to a cluster of either the first centroid or the second centroid. Okay, so let me repeat again. So if we choose this data point, now we know that this data point is closer to this cluster, this centroid. So this data point will belong to this to the cluster of this centroid. And if we look at this data point, now this data point is much closer to the second centroid as compared to the first centroid. So this data point will belong to the cluster of this will belong to a cluster of this centroid. So in this way, we'll basically assign which cluster to each data point belongs to. So after, let's say, after doing the same thing for all these data sets, what we'll have two different clusters here. Okay, let me do this more clearly. After applying k-means algorithm, we'll have two different clusters here. Now why we are having two different clusters here? Because we gave k is equal to 3. Okay, k is equal to 2. That's why we got two clusters. If we would have given k is equal to let's say 3, then we would have three centroids here, and as a result of having 3 centroids, we would have 3 clusters here. Okay, so this is how basically k-means clustering works. Okay, but the main thing here is the value of k. Before training the model, you have to it is upon you to give the value of k. Now, how do we decide the value of k? Okay, because right now our data set is very small, so we can easily say that okay, there are three, I'm seeing three groups here, so I can give the value of k is equal to 3 here. But what if you have millions of data points here? I mean, in that case it becomes very difficult. It will be impossible for you to like find similarities between those data sets. So for that reason, we have a special method called as elbow method. Okay. Now, in elbow method, uh, elbow method is basically a method that we use in k-means clustering to find the most optimal value of k. Okay, to find the most optimal value of k. So it's very simple. It's not that hard. Okay, so these are the steps that we'll follow to find the most optimal value of k. So the first thing that you have to do is select a range of values of k. Okay, here we trained our model for only one value of k, right? For only one value of k. So k is equal to 2. So what we'll do is we'll train multiple models on our same dataset with different values of k. So let's say we want to train our model for the values of k is equal to 1, 2, 3, 4, 5, 6, 7 and 8. Okay, so what we'll do is we'll decide upon a set of values for k. We'll decide upon a set of values for k. Okay, so now we have decided upon a set of values for k. Now what we'll do is, using elbow method, we'll find which value of k is the most optimal. Okay, so we'll see which value of out of this set of values is the most optimal value for our model. So we basically selected a range of values for k. The next step would be train a k-means model for each value of k in the set. Okay, so since we have 8 values for k here, what we'll do is we'll train 8 different k-means models on a same data set. Okay, just the value for k would be different for each iteration. Just the value of k would be different for each model. Okay, again, what we did was we basically selected a range of values for k, and we trained multiple k-means model for different values of k. Okay, now the third thing that you have to do is you have to calculate the sum of squared error for each model. Okay, for each model you have to calculate sum of squared error. Sum of squared error is nothing but basically mean squared error, but you just don't take the average here. Okay, so in our regression problem, let me just show you. Yeah, in our regression problem we saw that we had what we did was we took a squared sum of the entire error. Okay, we took a squared error. Okay, but just remember that sum of squared error is nothing but mean squared error without the average. Okay, if we remove this 1 upon n, if we remove this average factor, then what remains is basically sum of squared error. Okay, all right. So what we'll do is we'll find sum of squared error for each model. Since we have 8 values of k here, and we trained one k-means model for each value of k. So which means we have 8 k-means models here. Okay, so after training 8 k-means model, what we do is we find the sum of squared error for each model. Alright, so I will show you how we can calculate the sum of squared error. Okay. Okay, so sum of squared error is basically a single value. Alright, it's basically kind of like a loss function. Sum of squared error is like a cost function to k-means model. Okay, now how do you find the sum of squared error for the entire model here? So what we do is, in order to find out the sum of squared error for the entire model here, we have to basically first find the sum of squared error for each particular cluster here. So in this image you can see that we have 2 clusters. So what we'll do is we'll find sum of squared error for each cluster. Okay, and then at the end we'll add them up to get the sum of squared error for the entire entire model. Okay, so sum of squared error for one one k-means model is basically a single value. Okay, a single value. Now what we did was we have basically 8 values, 8 models here, and we trained 8 different models with different k values. So if we find so now what we can do is we can find the sum of squared error for each model, and we can create a plot like this. Okay, so we can create a plot of sum of squared error versus k values. Okay, so the y-axis basically represents the sum of squared error, and the k value basically represents the different set of values for k here. Okay, now this particular plot is called as an elbow plot. Okay, an elbow plot because it looks kind of very similar to a elbow. Okay, now what we have to do is, in using this plot, by looking at this plot, we have to choose the most optimal value for k, and the most optimal value for k will be present at the elbow point. Okay, so you can see here we are neither choosing a value for k for which the for which the error is high, and we are neither trying to choose a k which for which the error is low. Okay, basically if it was a regression or a classification problem, we would have chosen the k values that give us the lowest loss value here, but we are not trying to predict here anything. Okay, that's why what we do is we choose the k value that is present at the elbow point. Now in this particular graph, the value for k which is present at the elbow point is 4. Okay, so the most optimal value for our data set, for our model, would be 4. Okay, for your data set it would be if we did for any other data set, it would be a different value. Okay, so looking at the elbow plot, we can see what we have to do is we have to look at the elbow point here. This particular region is called as the elbow point, and we have to choose the k value which is present at the elbow point here, and that value would be the most optimal value for our model. All right, so moving forward, let me also show you how we can calculate sum of squared error. Okay, how, because sum of squared error is basically a single value for each model. It's kind of like a loss function for each model. Okay, so calculating sum of squared error is also very easy. Okay, it's not that hard. So now let me first create some clusters here. Okay, just for the sake of example, let's say this is one cluster, this is another cluster, and this is a cluster. So now in order to find the sum of squared error for this entire model, we have to find the sum of squared error for each cluster, and then we have to add them up. Okay, and the total sum of squared error that we will get will be the error for our entire model. So I will show you how we can find the sum of square error for one cluster. Okay. Alright. So now let's also create a centroid here. Okay. Since each cluster has a centroid, let's create a centroid here. Let's assume that the black point is basically a centroid. Okay. So now what we'll do is, what we have to do is, we have to basically calculate the squared error here, and this is the formula here. So what the formula says is, it's basically the summation of the distance between summation of the square of the distance between the centroid and the data points. Okay, so for example, if this is a centroid, okay, this star is a centroid, then in order to find the sum of squared, what we'll have to do is, we'll have to first find the we'll have to basically find the distance. Okay, we have to find the distance between all these data points, and then for each data point, what we'll do is, we'll square that distance, and then again we'll add it up. Okay, so for example, let me create this. For example, let's say the distance between, okay, the blue lines basically represents the distance. Okay, now let us say that, let me also assign distance to this edges. Okay, now let's say that the distance here is 2, and the distance here is also 2, and the distance here will be 3, and the distance here, let's do it 1, and the distance here would be, let's do it 4, let's do it 1 again here. So basically this black point is our centroid, and all the other data points are a part of the this cluster. Okay, and these values basically represent the distance of these data points from the centroid. So in order to calculate the sum of squared error for this cluster, what we'll do is, we'll basically square each value, and then we'll basically add them up. Alright, so let me just write this here. So sum of squared error would be equal to a square. Okay, so let's also calculate the square of each distance here. So the square for, let's say, 2 would be, square for this data point would be 4, and then again the square for this data point distance would be 9. Okay, then the square for this data point would be 2, then in the same way what I will do is I will square each value here. Okay, so 1 4 1. All right, sorry, 1 16 1. All right, so this is basically what we did was we created the sum. We basically squared each distance, and we are now adding them all up. So if we do the calculation here, so let me open up my calculator here. So 4 plus 9 plus 2 plus 17 plus 1. So the value that we get is 33. All right, so the value that we get is 33. Now I know this is very basic stuff, but it's necessary that you understand these things from the very core. Okay, so what we did was now we know that sum of squared error for this centroid is 33. Okay, for this centroid is 33. In the same way, let's say that squared error for this centroid is 44. And squared error for this cluster is 55. Then the total sum of squared error, okay, let me write this here. Total SSE would be 44 plus 33 plus 55. Okay, and then the value that we will get would be will be the sum of squared error for this entire model. All right, so the value that we get here is 132. So now the sum of squared error, total sum of squared error for this model, where k is equal to 3, okay, k is equal to 3 is 132. So in the same way, what we'll do is we'll do this for all the models that we have trained. Okay, so here the k values that we chose was 1 2 3 4 5 6 7 8. So we have 8 models in total. So we'll calculate the total sum of squared error for each model. Okay, and then at the end what we'll do is we'll just plot them up. Okay, we'll plot sum of squared error against the k values, and we'll then get a elbow plot like this. Okay, and whatever value of k that would be present at the elbow point, okay, that would be the most optimal value for k. Alright, so yeah, this is how basically k-means clustering works. In the upcoming video, what I will do is I will show you how we can implement k-means clustering using elbow method. Okay.